Okay, we are going to do Advent of Code. We're still going to do our regular Wednesday night stream for game development today, but I figured Advent of Code is something that I've been doing every year for the last 5 years or so, and it might be fun to just stream the process this time now that I have a lot of free time. So for those of you that don't know, Advent of Code is not a programming competition, but it's more like a programming jamboree of sorts. Basically, every December for the last, I don't know how many years they've been doing it now, probably 6 or 7 years, there is a programming problem that gets published at midnight Eastern every night between December 1st and December 25th, like an advent calendar. Like instead of getting a present, you get a programming problem. And people across the world kind of race to finish the problem in the quickest amount of time. I don't really have any goals of doing this quickly. It might take me a few days to solve particular problems. But I mostly do this to kind of keep the knife sharp. I've found that by doing this every year, the way that I program just changes a little bit. It's really just kind of good practice. And it also happens to be a great way to learn a new language. For the past couple years, I've been doing it in Rust. I don't really have that many use cases for Rust, either in my hobby work or in my professional work in particular. But it's a really interesting language to work with, both in good and bad ways that I've found. And I'll probably just continue doing Rust for this year's Advent of Code. One interesting issue is I don't think I've done any Rust probably for about 8 months, and I've forgotten everything about it. This kind of happens to me every single time I work with Rust. So a lot of this is just going to be me remembering how to use the language and seeing what has changed or what is different about it. So the format of Advent of Code is you log in typically with your GitHub account, and you're given this problem to solve every day. And each problem has 2 parts. Right now, it's only showing me the first part, and there's a text prompt for each one of these problems. And there's a kind of goofy Santa and the Elves North Pole story framing or narrative framing for the set of problems. But it ends up being a kind of math problem or programming problem for each day that you basically have to figure out how to solve by writing a little program. And the fun of it is sort of interpreting the text prompt into an actual sort of abstract problem, and then from there converting into a program that will run not necessarily the most efficiently, but generally the way this is set up is that the first part of each day's problem just sets up the abstract concepts in your head, and you basically type in the number that your program spits out, and then it gives you the second part of the problem, which then gives you a much larger scale version of the original problem. You have to make sure that your program runs efficiently and solves the problem in a way that doesn't take a million years on your computer, which is a lot of the fun of it. So the first thing I'm going to do for today, the first day's problem is usually like very, very trivial. It's usually just like opening a file, adding up a bunch of numbers, and then spitting it back out. But they get progressively harder over time. But for my first day, what I think I'm going to do is actually just set up my kind of coding and build environment so I can. The goal here is to really be able to run your programs, check to see if the answer is correct, and then rerun them quickly without having to spend too much time futzing around with the build. I happen to have a kind of framework or harness for this setup from previous years, so the first thing I'm going to do is just grab that whole repository for my GitHub profile, because I have the new computer. I actually I don't even have my previous work on this computer now. So let's go ahead and look for it. Yeah, it's been a while. So I have Advent of Code 2020 Rust, but I think I actually consolidated all these things into one repository. Let me see if, oh yes, Advent of Code here. So you can see I've been doing it for, boy, What is that, 6 or 7 years at this point. And I even did 1 year, 2018, in a couple of different languages, or at least I started to do it in a couple different languages. I was kind of into learning OCaml at the time. But yeah, for the last 3 years, I've been doing Rust. I haven't gotten any better at Rust, but whatever. This is my opportunity to work with it again. So let me just go ahead and check out the repository, and we'll go from there. Oh, clone. All right, so let's go ahead and crack this open in VS Code and see what we can make sense of here. And what we're really interested in is the, yes, I trust the authors, I am the author. What we're really interested in is the structure of our last year's problem. And you can see basically I created a directory for every single problem to solve, and each day actually has 2 problems. So each day is split up into an A and B. I have this name scheme to make sure that they sort correctly. And then I think the secret sauce of this whole setup is a Makefile. And the Makefile here basically will allow me to basically type make, well, let's give an example here, make day 01A. And what it'll do is it'll call the Rust compiler to build that day's project, and then run the resulting program and piping in the input for that day's problem. Advent of code typically has a text file that is full of inputs. And a lot of people just like paste that text file as a string into their source code directly if they're really trying to go fast. I put it in a separate text file so I can kind of examine it separately, and then I pipe it into my program using standard input. That's basically what my Makefile does. The Makefile has a bunch of kind of like shell magic that I always have to like learn how to do every single time I write a Makefile. But what it does is it allows me to specify in an automated way all of the separate programs that I'm running here. So what this call more or less does, it says, give me all of the directories inside my current directory that start with the letters D-A-Y, or day. And then from there, we can kind of build our projects. So let's just, maybe what I can do starting out is just kind of copy the important stuff. What's the README doing? Oh, the README is actually useful. It basically talks about how to actually build things. Oh, this is good. These are like kind of notes for myself. So what I'm going to go ahead and do is just sort of replicate this structure here. I'm going to go ahead and just like create a new directory. 2021 Rust. And why don't we go ahead and just save the README into 2021. And we'll also just make a couple of like cheesy edits here, 2021. Great, so far so good. I will also copy the Makefile and the git ignore. So that has me set up, and I don't even know, I just realized I don't even know if I have a Rust compiler. Do I have cargo? Yes, I do. Okay, that's a relief, because it probably would have taken me a long time to just get Rust installed. And then I noticed last year I also had a day 0, and I think what this was is just sort of like a test program. Yeah, just a test program that I used as a template. So I'm just going to go ahead and copy that. So let's see, 2020 Rust, day 0, and into 2021 Rust. Oh gosh. Every time I do a recursive copy, I never know if I'm like gonna copy the directory that I specify or if it's gonna go into the directory and copy all the files. So hopefully when I do this, it doesn't create a bunch of files at the top level of this directory. Let's see what happens. Okay, fantastic. It created day 0 in there. It kind of did what I wanted, so I lucked out that time. So I think in principle, I should just be able to call make day 0 and have it just spit out some output. Oh, I need to actually go to 2021 Rust. Duh. Okay, it's compiling. This is exciting. All right, I got a hello world. That's fantastic. And if we look at the structure of this directory in here, why don't I just open up 2021 Rust directly? That's actually going to be the directory that we're going to be working from for the most part. If we look at day 0, I have a cargo.toml file, which has no dependencies. It basically just specifies like what version of Rust we're using, or what version of cargo we're using, and what our dependencies are. And typically I don't really use dependencies for advent of code. There are 1 or 2 libraries that I find especially useful that kind of help backfill the Rust standard library, but by and large the Rust standard library is like pretty good. And if I need to write an algorithm, like a pathfinding algorithm or something else, I'll generally try to write it myself. I think the point of doing this is really just to be able to kind of, again, sharpen the axe a little bit, to really kind of practice writing some of these like basic algorithms or data structures from first principles. Now, I'm not going to write my own hash table, for example, or my own like kind of like resizable vector class or dynamic array class. I just basically use what the Rust standard library gives to me. I'm trying to think if there are any other common libraries I will use besides the lazy static. I'm sure there's other ones that we'll run into. But yeah, in general, I try to avoid dependencies as a general rule when I program, but especially when I'm doing advent of code. So because we've got enough going on here, I think what I'm going to do is just go ahead and copy day 0 and make my day 1A. And we're gonna go from there. Ugh, gosh, haven't even used a Unix shell that much. Okay, so day 1A is ready to go. Let's just make sure that I've gotten it correctly. Oh yeah, and there's an input file. You can actually see that this program is calling this get input function. And all this is really doing is grabbing standard input, locking it so that like Rust assumes that you're running a multi-threaded program. So any kind of like file stream or input stream, it's gonna want to make sure that you have that your current thread has exclusive access to it before you can get anything out of it. So it's gonna want you to lock it because reading out of a stream is actually mutating that stream, right? You're kind of mutating some kind of pointer, or you're discarding bytes that have already been buffered. So it just basically locks standard input, grabs, I think it probably just dynamically allocates some memory for you, and then just like shoves it into a point, like a reference to a string that you just created, and then it prints it back out. So if I look at this input file, I think it's just the word hello world. So I'll go ahead and call this hello world, hello world 2021, just to make sure that day 1A will compile, and then let's do make day 1A. What is it complaining about here? I think what happens when I did a recursive copy, it copied the target folder, and the target folder actually has some extra stuff in it already, so I'm going to go ahead and just delete this target folder. We don't actually need it. And I'm going to go ahead and delete the one from day 0. I think it's going to end up being my template, so I don't want to have to do this every single time. So I'm going to go ahead and just try recompiling there. Okay, so this may be an issue with the Makefile. This is weird. I'm coming back to this after so long, just trying to make sure I know what I'm doing here. Oh, actually the cargo.toml needs to be renamed every single time. So simply copying the directory doesn't work. That's what it was. Okay, hello world 2021. Fantastic. And I think we're pretty much ready to roll. I don't know why I like using this terminal. VS Code has a perfectly serviceable terminal in it, but there's something about it being small and down here that I don't like using. So we'll just try to plow ahead here. Let me just double check the stream in the Twitch app on my phone real quick, just to make sure things are looking good and sounding good. VS Code has a perfectly serviceable terminal in it, but okay, yeah, that's great. All right. So, oh, by the way, in about an hour and a half, we're going to do our regular game dev stream. So I'll have to make sure to hop off of that, 15 minutes ahead of time. and Dom will be joining us at that point. Okay, so let's go ahead and clear everything. Let's get everything out of the way. I think it looks like I've got Rust support already, so if I yeah, there's no definitions for some of these functions. I'm a little bit skeptical. Do I have Rust Analyzer installed? It doesn't look like it. Yeah. So if I get the Rust for Visual Studio Code, powered by Rust Language Server and Rust Analyzer. Okay, cool. This is what I wanted. They're like, at least a year ago, the default Rust plugin used the old version of like the Rust tool chain, and it didn't use Rust Analyzer, which is kind of like the new rewritten code intelligence package. And it's a little bit like Roslyn if you're a C# person, but it was quite a bit slower and not as good. So I'm gonna go ahead and install these tools, and I should be able to at least get definitions for these functions here. Some Rust components not installed. Let's see here. Oh, sure. Yes. Oh god, let's see what. Oh, it's installing Rust Analyzer. Yeah, Rust Analyzer is not just the Visual Studio Code extension. It's actually a full-on, probably like an actual little server program that will run in the background. Terminal will be used by task. Press any clicking. Okay, sure. I hope that did it. Rust Analyzer is here. Rust is here. I'm going to go ahead and just reload Visual Studio Code just for... It's generally a good practice every time you've installed a new extension. You have both Rust Analyzer and Rust Lang plugins. They are known to conflict with each other. That's funny. Okay, so I guess I'll just disable Rust for now and just use Rust Analyzer. That's weird. I don't know why it installed both of them for me, only to... Or maybe I had Rust Analyzer already. I can't... I don't really... I didn't pay attention before. I don't know what the source of conflict was. Or maybe what it is Rust Analyzer is just the old version of this. Let's actually take a look. When was this actually created? Because if you go to the Rust plugin, it says that it uses Rust Analyzer. Oh, either. It's a user preference thing. So maybe what I should do is actually disable this one here. I probably had it sitting around. Or let's actually just fully uninstall it. Yeah, I mean, well, it was last updated on the like a couple days ago. So maybe we should just roll with this. Yeah, this Rust VS Code plugin was last updated, wow, a year ago. Let's just get rid of it. Should probably pay attention to these things. All right, let's, again, for safekeeping, let's just completely start from a blank slate here. And now if I hover over this stuff, let's see. Not seeing any action so far. Oh, I disabled the plugin. Gosh. It's going to take me a whole hour to just get everything going in the brain. Okay, cool. You can see it's got a little bit of code intelligence here, and if I kind of hover over this, read to string, it's actually showing me the documentation for the standard library, which is fantastic. This is all you really need. Boy, I'm just looking at the Rust code all of a sudden, and I'm just like, oh gosh, I'm gonna have to remember how to use this language basically from scratch, which is fine. It's good. It's good to exercise that muscle. All right, so let's actually get into the problem definition. Advent of code. I'm gonna basically like save my own voice and save everybody else's sanity by not reading the problem. But once I read through it, I will just try to summarize it the best I can. All right, so we're collecting stars. Stars are basically equivalent to a problem. When you finish a problem, you get a star. That means you get 2 stars a night. There's 25 days in the Advent calendar, so we get 50 stars altogether. Okay, so there's this kind of funny submarine story. We're doing sonar sweeps, and oh boy, I'm now just thinking about all the different fun little gimmicks that Advent of Code problems sometimes have. A lot of years you have to build a little like CPU. Basically, the input to a problem will be a bunch of like essentially assembly language instructions that you have to process. The assembly language that they invent is like a totally like toy language. And then you may have to like kind of reverse engineer the program to figure out what's in there. Other problems that like that's a common theme is like basically doing language interpretation. A lot of this is like kind of like there's also parsing. There are also some game-like things where there's this sort of two-dimensional or grid-like structure, and you have to do a pathfinding problem over it, or you have to do a little simulation. The first day is not going to involve anything that complicated, though. Let's see here. Oh, I gotta log in. You should log in through here. Topaz. Oh, this sort of scared me for a second there. I was like, who's Topaz? Yeah, Topaz, you can get my limited public data. Okay, so the idea here is that you have a list of numbers, and for the first problem, we just want to check pairwise how many times do we have a number that is followed by a number that is one that is greater than the first number, right? Okay, so let's get into it. Let's just go ahead and like make sure that we're reading the input correctly. So let's grab my input. The input is I think different for everybody, or there's like there's like 100 different sets of input. They pre-generate 100 outputs based on that input, and that way they can check your answer really quickly. The reason why they randomize it, or they have 100 of them or 1,000 of them or whatever, however many they have, is just to make sure that people can't copy their answers from each other, which is totally reasonable. All right, so let's go ahead and like slap my input in there. And I think what I would like to do is just make sure that I can basically read these numbers correctly. So let me make sure that I'm consuming the input correctly is basically what I'm going for here. So what I want to do is actually split this by new lines first. I have patterns for this in my other in previous attempts at this. So let's just, for the sake of efficiency, look at some of the patterns for splitting strings and that kind of thing. I'm guessing that I can just grab this. So I grab the input, and then these are int64 value. They're integers. And we're basically splitting it by new lines over each substring, or each string that comes out of that. We are parsing and then unwrapping it. Rust is really cool in that it's doing kind of a type inference here. It knows that you want a vector of int64, so it understands. So the parse function understands, or the compiler will basically infer that what you're talking about is the parse function for integer 64s. Now, map, I believe, returns an iterator that we then need to essentially materialize into actually a new vector. Collect is a generic function, again, that like can mean that I want to collect into a dictionary or collect into some other data structure. But again, the compiler can infer that what you're talking about is a vector. So it will use the vector version of collect. So let's just go ahead and do that. Grab our input, put it into a vector. And let's just actually print the vector. Now, if I'm not mistaken, I don't think this is going to do very much vals. Yeah, I think what I want to do is debug print it. And I think I want a semicolon there, because otherwise I'd be returning the println value. Rust is an expression-based language, not a statement-based language. The last statement in every block of code is technically the return value, or what value the entire sequence of statements will evaluate to. And in this case, I don't want it to evaluate anything, or I want it to evaluate to essentially nothing, which is expressed by this value here. So I just put a semicolon there. Let's go ahead and run it. And I think here, because I don't want to jump between windows too much, I'll just try to run this from Day1A. Sorry. Okay, great. So I'm able to read the input successfully. Okay, so what we're trying to do is to find how many times the input increases. And I think maybe the simplistic way of doing this is just to do a really basic for loop, which we could do. A lot of times, like, you can do this in a fancy way where maybe you can create a bunch of tuples, like pairwise tuples, like let's group the first one with the second one with the third one, stick those into basically a list of 2 tuples, and then analyze all of those. You can do it fancy. I'm just going to try to do the most basic thing up front and see how we can go. So we're going to go from 1 to the number of values. Is it length? Size? Count? Vals.len. It's funny that I feel like, you know what it is, I'm formatting the for loop incorrectly. Once again, I am just like relearning how to do Rust from the ground up. And when I typed count, it kind of pulled in some extra stuff for me, which I don't want. So I'm missing a variable name here. For I in, right? Vals.len, there we go. So now we have I. And we actually want to go to length -1 because we're going to stop before the very last element. And what we're going to do is we're going to say the result is equal to 0. This is basically the result that we're accumulating. And we're just going to basically say if vals I is less than vals I plus 1, and this plus 1 here is the reason why we need the -1 here. Then res plus equals 1. And then we're going to go ahead and print the results. Doesn't like my plus e. Oh, it's immutable. Gotta mark it as mutable. And I think my parentheses are unnecessary. And great, we got a runnable program here. Okay, so 1721, that's what it says the answer is. We're just gonna go ahead and try it. My answer is too low. Okay, generally what happens if my answer is wrong, I could have made an egregious programming error, but more likely than not, I've just misread the problem completely. Oh, and I notice, is my program formatting? It's not. Okay, so once we get the right answer, I think the next thing I'm going to do after this is to make sure that I have a formatter working correctly. All right, so let's go back and reread the problem description, make sure we understand correctly. Count the number of times the depth measurement increases from the previous measurement. There's no measurement for the first measure, before the first measurement. Okay. Okay, so one thing we can do is just copy the sample here and run our program over that and make sure that things are working correctly. So I'm gonna go ahead and just like delete all this stuff. I think I can do this. Yes, excellent. All right, so let's go ahead and run our program over. Okay, so we're off. Using the sampling, but it kind of looks like we're off by 1. Does that mean that vals minus len minus 1 is the wrong answer? So let's think about this. Let's say we have an array of 3 elements. Vals len would be 3, 3 minus 1 would be 2. We don't actually want I to ever be 2. The last one that we want I to be is 1, so that actually looks okay. We'd be comparing 0 to 0 plus 1, which is 1. And then we'd be comparing 1 and 1 plus 1, which is 2. And then we should be able to break out of that at that point. Interesting. 199 to 200 is 1. 200 to 208 is 1. That's 2 so far. 208 to 210, that's 3 so far. 210 to 200 is no. 200 to 207, that's 4 so far. 207 to 240, that's 5 so far. 240 to 269, 6 so far. 269 to 60, nope. 260 to 263, 7. So I think we're basically getting it. Now let's go ahead and just like print everything. I don't really know how to debug effectively in Rust other than to just debug print, which is a totally fine way of doing it. All right, so 200 to 208. So we're actually missing the first. Oh, because I started at 1. That's my off by 1 error. That's silly. So I think we can actually just go back to our original input. I bet we were off by 1. What we got before 1721 was probably 1722 was the answer. In fact, I'm gonna go really daring here, and I'm just gonna punch that in. 1722. Yep, got it. And let's just actually make sure that the program does it for us. If I was in a huge rush, if I was really trying to finish this as quickly as possible, I do this kind of thing where I just guess what the answer is. There are times actually where I've been off by 1 and just couldn't figure it out. And so I did actually cheese the answer submission where it was like, okay, I think like I'm using the sample input, I'm getting the right answer, but I'm kind of like off by 1 or off by a little bit. So I'm just gonna like try a couple of numbers in the vicinity of the number that my program generated and see what happens. Not super satisfied about that. Sometimes I'll go back and try to fix it. In this case, it wasn't necessary. Okay, so let's go ahead and try to figure out how to do day 2 now. And this is going to be, I think, significantly harder. Let's go. Oh, sorry, not day 2. Part 2 or part B of day 1. Okay. All right, so we're going to make it more complicated. Okay, so this is just a little bit more complicated. What we're doing is we're basically saying, let's take a group of 3 numbers that are adjacent to each other. We're going to total them. So that's sum A. And then we're going to slide up one number, take the next group of 3, sum them together. That's sum B. And if sum B is greater than sum A, then we add 1 to our result. So what we have to do in this case is just make sure that rather than compare it to the next one, we need to compare it to the next 3. So I basically want to subtract 3 from here. And so what we can do here is just say files I plus I plus 1 plus I plus 2 is less than oops, I actually should make sure to save this into a separate directory. You wouldn't believe how many times I clobber my original answer because I've saved over it by accident. So actually what I'll do is let's go back. Let's actually use our tools. Let's use Git to make sure I can recover from these types of situations. And back it up to GitHub, why not? So So now what I can do is cp-r day 01A, day 01B. Let's go ahead and go to day 01B and make sure that I increment the name of the cargo package. For these programs that are this simple, I usually just don't even need to use cargo to build and run my programs, but I find that just having this template is a little bit easier. Because eventually at some point I'll probably need to start using dependencies. So let's make sure that day 1B runs. All right, it runs. And I have in my clipboard my changes that I added here. And I believe this was a 3. Let's see, am I off by 1 here? I'm gonna go -3. So length, the last number that I'll get to is length minus 3, length minus 4. I have a feeling that I might be still off by 1 here. This might need to be -4, but let's go ahead and run it and see if I get like an error. Okay, well, it worked. Let's see, 1748. Let's just see how it goes. All right, well, we got it. Wonderful. All right, so we finished. Finished with that. All right, so now what I'd like to do is actually just make sure I can get auto formatting. So let's just see if there's a Rust format VS Code extension. Looking a little dodgy here. Let's see. I'm actually surprised that the Rust plugin doesn't have it, but it is Rust Analyzer, so maybe. I actually had to write a special thing for this in the past because Rust format didn't really work all that well. This was last updated in July. It's been downloaded 20,000 times. Let's just try it. Yeah, the issue that I would have using Rust format in the past is that Rust format operated across an entire directory. It didn't really have great support for running it on a single file. And so I wrote a whole little like sed script or awk script that would just pull out the output of Rust format that was relevant to the file that you were saving, and then basically tell VS Code to save that. It was a whole hot mess. I'm hoping that this will just work. So I added that formatter, and then let's actually open my VS Code settings. Sure, let's do the whole thing, and then what I kind of want is like the language settings, which I think is probably going to be easier to read in the JSON. Yeah. So what if I did this? I am guessing that Rust looks like this. Sure, let's have a tab size of 2. Why not? And let's go ahead and reload. Let's let this little guy finish spinning. I'm saving and not seeing anything. It could be that there's errors. Let's see. Tasks, extensions. Well, what if I just went to format and see? All right, so there are multiple formatters. Oh, Rust Analyzer is a formatter, apparently. All right, it's formatting now. That's interesting. All right, so I guess I don't need the thing that I just installed. See you later. music to my ears. Let's reload again and just make for damn sure that that was working correctly. All right, it works. For some reason, the tab size isn't maybe it's because it's like trying to infer the tab size. I would have thought that Rust Analyzer would be able to use this, but let's go ahead and just get rid of the tab size. It seems like there's an opinion that Rust Analyzer has. I don't want to contradict that opinion. I don't really care about the tab size too much as long as it's not longer than 4 spaces, so we're good here. All right. Let's see if day 01A has any formatting issues. Let's see. Nope, looks good. Well, let's see. Did that cause any changes? Yeah. So a few formatting changes. Let's go ahead and just push those up. Sometimes I like to go over to GitHub and just make sure that the repository looks nice and clean. Rust. Go in here. Okay, so far no weird files, directories. We're looking pretty good. And yeah, that was pretty quick. We shouldn't expect that every day is going to be this simple in Advent of Code, but the first day is always just like a nice kind of like, you know, get the temperature of the water, kind of stretch your legs a little bit. I don't think that there are vastly superior ways of doing this particular problem than what I'm doing here. I used to want to do it like the clean and clever way. Nowadays, I kind of just go for what's most straightforward and what's most easy to read coming into later. Sometimes the clever way is easier to read. But in this case, I'm thinking what we've got here is pretty straightforward. Stylistically, sometimes I kind of go back and forth on whether I move expressions like this into their own variables. I tend to have fewer temporary variables than more these days, unless it really affects readability. Here, you know, on balance, it's fine, really. So yeah, I'm trying to think, are there any other things that I would do to change this? I guess there are maybe ways that we could use idiomatic Rust to group these together. I think there might be a way of doing that. But again, I really feel like this is pretty straightforward, easy to read, not too clever. Great. So I think that's it for Advent of Code for day 1. I guess we'll pick it back up tomorrow, or if I'm really feeling like doing more code tonight, I could do it at 9 p.m. tonight, which is 9 p.m. Pacific, which is when the next day's puzzle gets released. All right. Well, that's it for us today. I will see you in an hour and 10 minutes.